Welcome, everybody. My name is Patrick Fetterman, and I'm the VP of Products and Marketing at Sight Machine. I'm going to be the main presenter today, but I'm going to be joined for the Q&A section by Ryan Smith, the leader of our data acquisition team. When you look at a factory today versus 10 or 20 years ago, there's some obvious changes, of course. One of the most obvious is the number of people. I was in a plant a few weeks ago, an automotive supplier making drivetrain parts, and I was shocked at how few people there were in this whole plant. Yet they were running 24 hours a day, 7 days a week in order to keep up with the demand from their customer base. The enabler for them, of course, is automation. There were robots and automation systems everywhere you looked throughout this plant. And that's a pretty common theme in factories today. Less obvious, though, is what's going on behind the scenes. If you look at the blue boxes on the screen here, highlighted in the photograph, we've called your attention to all the multiple data sources, even in this small area of a factory. There's temperature and pressure sensors, there's a PLC, there's a whole bunch of things scattered even in this very small area. In essence, every machine in your factory is now able to talk, all of them. And the language they speak is the industrial internet. There are many, many formats of this data, many languages, so to speak, and if you're not listening to them, you're missing out on something that can fundamentally change how you manage your business. This has been a kind of a subtle change that's taken many years to reach this point. But for the last 10 plus years, manufacturers around the globe have been investing more than $100 billion, that's billion with a B, per year in automation technology. Gartner Group just released a study this week, came out on Tuesday, I believe, that says next year in 2015, there'll be 4.9 billion things connected to the internet. That's things, not people. A lot of those things are in plants like yours. That advancing wave of data producing technology has put us on the cusp of the next manufacturing revolution. And I think it's helpful to take a moment here and review how we got to where we are today. The first industrial revolution was about the rise of factories and innovation around standardized replaceable parts. We all remember that from our grade school history books. After that came distribution systems with the railroads and the rise of consumerization with electrification of homes and plants. And the population moved to industrial cities around the world. After that, of course, Henry Ford, he's well known as the pioneer in the next major wave, the assembly line, which was a great process improvement. And for the next 75 years or so, all of the great changes in manufacturing have come from process improvements, including the rise of lean manufacturing or the Toyota production system, and quality initiatives like TQM back in the 80s and Six Sigma more recently. The Toyota production system and Six Sigma in particular drove greater interest in the systematic use of technology and information from the factory floor, which in turn drove investments in the technology on the floor to track that information. And that's how we got to where we are today, in the rise of the industrial internet. And you might be asking yourself, if manufacturers have been investing in automation and this technology for 10 or 20 years, why is this so much in the news right now? And there's a pretty good answer for that. That's until the last few years, the technology and tools needed to make sense of all of this data have not really been available to most people. Recently, however, there have been several advances in information technology that have finally brought all of this together. These advances include a brand new branch of data science, generally called big data. I'm sure you've seen this in articles and in presentations around, that offer new tools for correlating and analyzing multiple types of data. You'll hear us talk both about structured data. That's the kind that's easily tags and fits into a standardized database. And there's unstructured data. That's the kind that doesn't have a standard row column database format and thus doesn't fit into traditional systems very well. That's things like paragraphs of text, images, etc. Coupling these advances with the rise of standards for machine communication protocols, the ongoing investments in automation and sensors, and the rise in particular of inexpensive storage and computing power via cloud-based systems, and that's how we got where we are. This is why the pieces coming together have given rise to the industrial internet. in the situation we find ourselves in today. And it's a good thing, too, that all of these have come together, because market forces have really fundamentally changed the game in manufacturing. All of us have heard this many, many times before, but looking back over the last 10 to 15 years, we see much higher quality standards, both from consumers and from our customers in our supply chain. Tighter regulatory environments, especially in automotive and medical device, and more recently in food processing. And the reporting requirements that go along with it. There's been a very dynamic labor situation both in the U.S. and globally. Companies that offshored production for labor force costs are rethinking those decisions because costs have risen so quickly in places like China. We've seen faster cycle times for new products. Again, going back to automotive, I think when I was a kid, the standard refresh cycle for new automotive designs was in the 6 to 7 year time range. We're now seeing 4 years as a standard and getting down to 3 years in some cases. And even emerging trends like the mass customization of products are all pushing harder and harder on manufacturers. If you're not familiar with mass customization, take a look at the Nike website. This is kind of a cool thing. You can start with a basic shoe that they manufacture, and you can customize its look, anything you want, colors, patterns, etc. And in a few weeks, Nike's going to send you a bespoke shoe just to your specifications, your size, your colors, everything. Tesla's doing the same thing with cars. Levi's been doing it with blue jeans for a long time. M&M Mars allows you to order M&Ms with your custom message on them. And I'm sure all of us have seen the Capital One commercials that allow you to upload your own image, your own photo, for printing on your credit card. So there's, the examples just go on and on and on. And you can imagine the complexity this adds to the manufacturing process. All of these new pressures, all of this complexity, all land in the same place, the factory floor. Trends like the ones I just talked about are demanding new processes and new technologies and access to the data that's being produced on the shop floor. And they are really some of the key drivers for the increasing spend on new digital manufacturing technologies and manufacturing intelligence technologies as well. I love this message, this acronym DRIP, Data Rich Information Poor, because we see this problem so often when we're out talking to manufacturers. They all seem to have the same sort of problems. They're producing data, they know they're producing it, and sometimes they're collecting it and collating it, but not in any standardized fashion. What we hear from them, and this is such a typical story, is that when they need to do some sort of analysis or report, they send a manufacturing engineer down to the plant with a thumb drive. And he goes from system to system, collecting the data that's there, brings it back to his desk, imports it all into an Excel file, and spends a couple of days organizing it, sorting it, and creating some sort of report from it, which he then usually distributes via email. I don't think anybody's going to call that a best practice. Very few people trust that data. It's certainly not timely data, and it's not an easily replicable process. So clearly not a best practice in manufacturing. So this DRIP acronym is a really great identifier, I think, for the problem. This lack of insight caused by being data rich and information poor creates all kinds of problems, right? So we've seen a fastener company doing destructive testing and manual visual inspections that just can't keep track of their data. We've seen an automotive OEM that has a dozen different data systems and uses interns to enter data from one system to another. We've seen a global footwear maker who started automating their entire process without thinking about all the data gathering and analysis to provide them insight into their processes. And we've heard it all. We see these situations at every manufacturing company we talk to. Everybody we talk to knows they should be collecting data. They suspect they need it to reduce their scrap and rework. They think there's some really good insights they can gain from this. And when we talk to people in their warranty and claims in their quality department, they all want that data to protect themselves from warranty claims, because we know that those are getting pushed down from the OEMs to tier 1s, tier 2s, et cetera, not just in automotive, but across multiple manufacturing industries. But the problem is the tools and technologies to do this are so new that they don't really know where to start. I would bet that most of the people that are listening in here today have some sort of skunkworks project going on. You might not even know about it, but there are people in your plants. One of your engineers has stood up an Access or a SQL database someplace to collect at least some information, but it's still not readily accessible to everybody. You're not sure if you can trust the data and the reports that you're seeing about data, and it's certainly not a scalable process for all of your lines, all of your plants. So here we are, right? Your factories, we know, are generating incredible amounts of data, but most of it is sitting unused. Companies are going to spend more than $200 billion in a few years on automation technology, on machines that talk, but most of them are still not listening. They may have a very strong controls network in place in their factories, but there's no data store, no modern software layer that brings intelligent analysis to that data. And that is where Sight Machine comes in. We're not going to talk about Sight Machine just yet, though. There's another issue that I want to talk about briefly before we move on and talk about the solution that we provide. It's a subtle thing that we haven't covered yet, but it's an important one. There are actually two types of data that most factories are generating, with two different groups wanting access to it and using the data. We often find that these two groups don't really communicate with each other. I'm talking about parts data and process data. The quality team monitors as much data about the parts as they can get. They're looking for defects with visual inspection or machine vision systems, with digital gauges and other tools. They report out the data with control charts. They apply risk assessment and mitigation techniques up front as they're creating new process routing and supply chain solutions. And they play defense, really, against the problems that they know are going to rise up someday. So they're really on the defense most of the time. The other group is engineering and operations, who are monitoring the processes taking place in the factory, right? This is what they're all about, process, process, process. Their goal is efficiency. So they monitor machine downtime, they look at cycle time, tool usage, maintenance time, much, much more. And they report things out as overall availability, or OEE is a very standard report that we see, downtime, Pareto charts, etc. The problem here is that the two types of data, the parts and process data, are really inextricably linked. They should be looked at together, but they're usually kept separate from each other until a problem occurs, and people try and dive down into it. The demand that we've talked about for a modern software layer to address the factory data challenge really needs to address both types of data, both groups' needs, and do it in a seamless fashion. So there really should be no differentiator between parts data and process data within your systems and within your factory. So now let me talk about Sight Machine and our platform just for a moment. Sight Machine is a 3-year-old company that was founded to address exactly this data challenge, using the latest technologies from the worlds of big data and cloud computing. Our solution can really be looked at as a 3-layer architecture. You see the 3 boxes here in front of you. The first layer on the left-hand side is the data collection layer. It uses a series of standardized connectors to collect data from a wide variety of sources. That means your PLCs, sensors, cameras, robots, even in some cases pulling data out of your ERP, your MES, or your quality management system and collating it together. Once this data is collected and it's inside our system, the middle layer, the data management layer, that engine utilizes a variety of techniques to aggregate and collate the data into usable formats. And the third layer, our applications, then presents the results of that analysis in a variety of applications supporting areas like quality, traceability, and operations, all kinds of operational insights and product insights, and it's available in real time. From a practical point of view, the system usually includes a small industrial computer installed somewhere within the factory, and that collects and aggregates data from the sources in the factory. The server is then connected to our cloud architecture where the analysis and the applications run. That means users with appropriate permissions can log on from virtually any web browser, regardless of their location, and get real-time, up-to-date analysis of what's going on in the plant. So if you have a factory in China, for example, Sight Machine can give your operations and quality people in the U.S. real-time insight into those Chinese operations without ever leaving their offices. That is really the value of cloud computing nowadays when layered onto a factory system like this. And the outcomes we've seen from our existing customers are pretty remarkable. We've seen, of course, dramatically reduced scrap and rework. I mean, that almost goes without saying once you get the information about the processes. Dramatically increased OEE, that's a number that almost all of our customers are tracking. Better overall performance of their manufacturing operations is really what it comes down to. We've seen one customer wants to use the Sight Machine reports when pitching to new customers. So they're using this layer of intelligence to win new business and increase revenues for their company, which is pretty remarkable that people have that vision for really a manufacturing intelligence system. The platform was designed to be very scalable. We can start with a single machine or a single cell within your operations. We can scale to across an entire factory, across multiple factories, pretty seamlessly and easily. The architecture combines some open platform resources, cloud-based resources, the big data science that I talked about earlier, and software as a service for the applications to solve these recurring problems in manufacturing. So the data we collect is transformed into some usable models and real-time analytics, including there's time-based models, there's structured models, looking for outliers and shifts. There's all kinds of reports and reporting structures we can look at. And that includes, again, we look at outputs and applications like OEE, again, very popular in our customer base. Component checks, predictive and preventive maintenance are very, very big. Root cause analysis, of course, tying together root cause with the material identifiers for true traceability. Supply chain correlations is another output and a report style that we look at. And more are looking at green initiatives as well. So companies that want to track energy usage, both for a costing model and for corporate green initiatives, energy utilized during different times of day. We've seen some larger manufacturers who have negotiated contracts so power is less expensive for them in the evening or overnight hours rather than during the standard work days. Tracking all of that stuff in a single system is what Sight Machine is all about. So we can integrate these results into your existing systems too. So we provide all these standard reports, but if you'd like to see the outcome of these in an ERP system and QMS system, quality management system, or a manufacturing operations system or a manufacturing execution system, we support integration with all of those as well. Pretty seamless via standard APIs and web services. There is one customer that I'm going to talk about today with a little more specific detail. I can't give you a whole lot of detail. I can't give you any identifying information about the customer, except to say that it's an automotive OEM, one of the big ones. They started working with us this past year to tackle a very difficult quality problem in one of their factories. And it was a problem that resulted in millions of dollars every year in warranty claims. It was a big issue for them that they were throwing a lot of resources at. The analysis we provided in real time on their line ended up catching 6 times more of the defects than they expected. Huge cost savings for them. And so, of course, we're now looking at moving to the next phase of the relationship. More plants, more problems to tackle, and overall more savings for them and more happier dealers and happier customers with fewer warranty claims. That really is a good snapshot of what Sight Machine does for our customers. And that's really the end of our slides today. We do want to open it up. It's a relatively small group here online to questions. There is a text box on your screen in the GoToWebinar toolbar that allows you to submit questions. So I'm going to take a look here. I'm going to invite my colleague Ryan to answer questions here with me. Let me see this. What differentiates you from services such as those offered by IBM? So many big companies like GE and Cisco are talking about this space. Where does Sight Machine fit in? That's a great question. In fact, I saw an announcement this morning from SAP as well, saying that they're going to address this space. And the truth is, there's going to be a little bit of a land rush here. There are people, traditional major players in factory automation who are going to be addressing this market in one way or another. However, we believe that most of them are going about it the wrong way. They're using traditional enterprise software technology, SQL databases, et cetera, which are limited in their scope and do not allow you to look at the amounts of data that are being generated today in any easy fashion. SAP, for example, is doing most of this in an on-premises model. The amount of storage required within their ERP system to handle factory data is quite expensive, not really an optimal way to solve the challenge here. We will, in many cases, work with companies like Siemens, GE, the PLC providers, the machine providers, as well as some of the ERP MES providers, in order to make sure that the analysis that we do ends up in the right place for our customers to make the most use of it in real time. We have another question here about pricing. So what is an initial investment? Pricing varies pretty widely depending on the scope of the challenge, anywhere from a few $1,000s a month to tens of thousands of dollars per month, based on the number of data points we're collecting, the number of data sources that we're connecting to. So we'd really need to delve into it in more detail for detailed pricing in any given situation. The next question, is there a historic data logging long-term raw data storage? I'm going to defer that one for a few minutes and skip to the next question, which is, do you offer pilots for companies looking to develop these capabilities? We do offer smaller projects. As I said, we can go in with a single machine or single cell for larger companies, but it's on a case-by-case basis. We don't have a standard pilot that we go into in every case. How do you correlate the data from the different sources to know which ones affect each other? Nate, you should be online now. Can you talk?
Hi, Patrick. How are you doing?
That's great, Nate. Thanks for joining us. Yeah.
There's a couple different techniques that we use. One of them is pretty sort of standard anomaly and rare event detection. So we expect to see certain patterns over the course of production, and if certain anomalies pop up, our system will detect them. Now, not all anomalies are the result of problems in a production process. They can be problems from supplier. They can be just problems, from upstream. So you have the ability to kind of either flag ones for investigation or just ignore it. As far as establishing correlations, our analytics framework lets the operator go and take a look at specific things. So if you have a particular type of defect or a particular error on a machine that occurs a certain number of times, you can weigh that against different factors, and our system will tell you if there is a correlation, if it's statistically significant across a wide variety of data sources. And so we kind of do the stats for you.
And looping in on that, it's kind of like a fire alarm. If it's going on too much, then it's not very useful. So you only want to be alerted when there's relevant information. And also backtracking a little bit on the raw data, we do store all of the raw data, and that's kind of a big data approach to these things. So we'll have a retention policy, what makes sense from a storage perspective, but in big data terms, you often don't really know what you're looking for. So you might receive a bunch of information off your machines, and you think you're looking for one thing, but then in the future you have a problem that you say, it'd be really nice to start looking at this other information that we've acquired. And so retaining that is the first step, and we've really been surprised with the amount of value we've created in just logging stuff, especially images, that there's other sources that you might look at in there that you didn't originally spec for.
That's great. Thanks, Ryan. I'm glad we got you unmuted there. And that the other speaker is Nate Ostendorp, one of the founders of Sight Machine. So thanks, Nate, for jumping in. There's another question here, which is, do you have recommended hardware providers for the PLCs, cameras, et cetera, that Sight Machine works with best? Ryan, that seems right up your alley.
It does. So we work with all the major players, Allen Bradley, Siemens, Mitsubishi. Anything that works with OPC we can work with, and we have a pretty flexible architecture in terms of being able to pull information in without it being a huge pain point. With that said, if you're using some more proprietary technology, usually it's pretty cost effective. If we need to do a little bit of professional services up front to talk to something that we haven't seen before, over the scope of monitoring for years potentially, it's not a real prohibitive cost. So we try and be flexible that we can sit down and say, yeah, we've seen most of the common stuff, but if it is kind of esoteric, it generally works out.
Great, guys. It looks like that's it for questions. So I want to thank everybody for coming. We are finishing up just a few minutes early here today. And I just want to leave everybody with a few final points. So we really are true believers here. We think there is a gold mine of data out there in your factory, but we know it's difficult to get access to it. So if you think of one thing the Sight Machine does, it is that three-tier structure, that collecting data, analyzing it, and presenting it in easy-to-use formats for immediate actions. And we didn't talk much about implementations today, but because of our kind of hybrid on-prem cloud architecture, we can do pretty straightforward and fast implementations for a single machine or cell, and then scale to an entire factory very, very quickly. So that's what I want you to take away from this today. When you think of Sight Machine, think of that architecture, think of factory data, and think of immediate actionable reports for yourself. So thank you, everybody, for coming. We will be reaching out to many of you after this. There's contact information on the screen now. If you have follow-up questions, we'd be happy to talk to you, to any of you about that in the coming days and weeks. Thanks very much.